All right, I'm back. All right, where are we? 27. Limit x approaches infinity. X to the fourth minus 3x squared plus x over x cubed minus x plus 2. All right, well, if we check the top, infinity to the fourth, that's going to be huge. These are going to be smaller terms because it's squared and then it's just linear. So this should overpower everything here. So we should just get infinity, right? These are also infinite, but one of them is negative. So you might be thinking, well, this is infinity minus infinity. It is, but this one is overwhelming it because it's to the fourth power. On the bottom, same sort of thing. X cubed is kind of dominating this expression. So we should get infinity over infinity when we look at the limit. So I'm going to do what we've been doing when we had polynomials in the denominator. I'm going to try and get rid of the highest power down here. So I'm going to introduce a 1 over x cubed and a 1 over x cubed. And I'll pass that through and see what I get. So limit x goes to infinity. And then pass through. Now notice here to here, I'm going to be x to the fourth over x cubed. That's just an x. And then minus, we get 3 over x, and then plus we get 1 over x squared. So that's distributing through the top. And on the bottom, we get 1, which was what we wanted. Here we get minus 1 over x squared. And then here we get plus 2 over x cubed. And now let's let x go to infinity and see what happens. Some good stuff happens here. We get 0, 0, 0, 0. But here we're left with x over 1. And so x is going to infinity. This is going to infinity. Infinity over 1 goes to infinity. So we actually don't have infinity over infinity anymore. We have infinity over 1, which means that this goes to just infinity. So infinity over 1 is not a problem. All right, let's look at 28. Limit x goes to infinity again. Sine squared x over x squared. All right, so if we let x go to infinity, sine of infinity, that's kind of a weird one. Here's sine function. As you go to infinity, it just oscillates back and forth. So this limit actually doesn't even exist. And then the one on the bottom here, this goes to infinity. So the top limit is oscillating. That's what sine x is doing. You square it and it's always positive. So when you look at sine squared, it looks more like you cut off all these negatives and it kind of just looks like a bunch of bumps like this. But what's most important is that it's not headed to anything in particular. So this limit doesn't exist on top. The bottom becomes infinite. So what we have is a special case here where we have to notice that sine squared x is always going to be bounded. It's going to always be less than or equal to 1 and always bigger than or equal to 0 because we're squaring something that's got to be positive. The worst case scenario could be 0. So this numerator is bounded. And the denominator goes to infinity. And anytime we see something bounded over infinity, this thing goes to 0. And there's no more work to do. You just need to state that it was bounded over infinity. All right, let's look at 29. Limit x goes to infinity of cosine x. So this one, cosine looks like this. And as you go to infinity, it's not headed to anywhere. It just oscillates. So since cosine's the only thing in here, this limit just doesn't exist. Done. 30, let me do 30. This one's a little bit different because we're going to go to negative infinity instead of positive infinity. So let's try and see what's going on here. Limit x goes to negative infinity of 1 plus x to the 6th over x to the 4th plus 1. Now when I plug in a negative number into this and make it really big, it doesn't matter because I'm going to the 6th power. This can be a huge positive number. This can be a huge positive number. So you're going to get infinity over infinity. So I'm going to do what we did earlier. I'm going to try and get rid of this highest power. So I'm going to come in here with a 1 over x to the 4th and a 1 over x to the 4th. And then this would be, let's see here, 1 over x to the 4th when we pass this through, distributing. And then we get plus x squared over, x squared over 1, which is just x squared. It's x to the 6th over x to the 4th, so that's x squared. Then here times here is going to be 1, and then plus 1 over x to the 4th. And as x goes to negative infinity now, this is a negative number to the 4th power. It's going to be a positive number, huge positive number. That's fixed. That goes to 0. Same thing here. That goes to 0. And all you're left with is x squared over 1. And if x is going to negative infinity and you square it, it's going to be positive infinity. So that goes to positive infinity. All right, let me do number 31. I think this will be, I'll let you do 32 and 33 on your own. All right, limit as x goes to infinity of x minus root x. Now, this one is going to infinity minus infinity. And you see a root in there, so we could do a conjugate, but I'm going to show you a slightly different technique for this one. I'm actually going to try and turn this subtraction into a product, but without the conjugate. So what I'm going to do is I'm going to realize first that this is actually x minus x to the 1/2. That's just rewriting it with rational exponents. And then I'm going to do a GCF. I'm going to factor out of here a common factor, which would be x to the 1/2. And I know that looks a little weird, but if I pull an x to the 1/2 out of both of these, when I pull it out of here, I should have a -1 back here. But then what do I need here to get this back if I multiply through? Well, how about x to the 1/2? So when you multiply these two together, you add the exponents. 1/2 plus 1/2 is 1. So that would give you back this. Now, the reason why this is good is because if I rewrite this, and this step isn't necessary, it's just to kind of remind you of what you have here. It's root x times root x minus 1. If now I let x go to infinity, this is multiplication here. This is infinite. This is becoming infinite times, this is infinity minus 1. That's infinity. And infinity times infinity is infinity. All right? Infinity minus infinity, don't know. Infinity times infinity, yes, we know. That is infinity. So we're done. Okay, I think I'm going to let you mess with 41, or will you do 32 and 33 on your own? 41 and 49, I think I'm going to let you do. All right, hope that helps.